Okay, we're graphing exponential functions. So we're taking a function like y equals 2 to the power of x, and we're graphing it on a grid. And then we're going to start applying different transformations. So for example, let's say we went to the power of x plus 1. So that's going to make our whole entire graph shift, every single point shift up one space. So instead of our asymptote being at y equals 0, our asymptote's now going to be at y equals 1. And our new graph is going to look like this. So that would be a graph of y equals 2 to the x plus 1. We can do things like y equals 2 to the x plus 1 up here. And that's actually going to make all of our red points shift 1 to the left. So they're all going to shift over 1 to the left. So it's going to have the exact same asymptote. It's going to look like that. We're going to graph things that have stretches and reflections. So we could stick an a value out front of y equals 2 to the x, and that's going to be a vertical stretch of 3. So all of our y values are going to get multiplied by 3. So that's going to be up there. 2 times 3 is 6. 2, 3, 4, 5. It's going to be up there. A half times 3 will be here. So it's just going to make our graph stretch, but it's going to have the same asymptote. So we're going to apply a whole bunch of different transformations. So let's check out all the details. So it's exactly the same stuff you guys learned for quadratics, reciprocal functions, square root functions. So let me just fill in all the letters for you. So if we're going to start with a graph like y equals 2 to the x, there's going to be the a value that goes in front, k that goes in front of x, minus d, plus c. So that's all of the possible transformations we can do, and they all mean the same thing that they meant before. So a is our vertical stretch, and it's also our reflection in the x-axis if it's a negative value. And it's a vertical stretch if the value of a is bigger than 1. So if a was like 2, 3, 4, 5, 6, it's going to be a stretch. And you kind of just ignore the negative, because even if it's negative 2, negative 3, it's still a stretch. Whereas it's a vertical compression if a is in between negative 1 and 1. So if a is like a half, a quarter, it's going to be a compression. Okay, then we also have k, which is like the opposite of a. So k is going to be our horizontal stretch and compression. So horizontal stretch if k is in between negative 1 and 1. So if k is like a half, a third, a quarter, it's going to be a stretch. And then it's going to be a horizontal compression if the absolute value of k is greater than 1. So if k is like 2, 3, 4, 5, 6, or negative 2, 3, 4, 5, 6, it's a compression. And we're also going to have a reflection in the y-axis if it's a negative k. So these are like the exact same things as last time. And then d and c are pretty straightforward. So d is going to shift our graph left or right. And because we have a negative sign here, you just got to be careful. Because if d is actually a positive number, it's going to look like this in the brackets, d minus 3. So technically d is actually positive 3. So this would move your graph right 3 spaces. Okay, and then the final one is c. And c is going to shift your graph up or down. And it's exactly like it sounds like. So if it's plus 2, it's going to shift it up 2 spaces. So those are like the 4 possible things that could happen to your graph. And just like in BEDMAS, we always apply them in the same order. So we always apply pretty much in the order you see them. So we're going to apply stretches and compressions first. So A and K get applied first. A and K are first, and then D and C are second. So when you're applying transformations to a graph, you always do it in that order. Okay, so let's check some out. Okay, so this time let's say we start with the graph of y equals 1/2 to the power of x. Okay, so let's see what's going on here. We got y equals 1/2 to the power of x minus 2 plus 1. So what is that minus 2 doing to our graph? Well, it's shifting it right 2 because that's a D value. And this plus 1 is shifting it up 1 because that's our C value. So if we were to graph 1/2 to the power of x, I know, I graph it in yellow actually. Okay, sorry. I know that it's going to go through there. It's like the, okay, 1, 2, 3, 4, half, a quarter. Doesn't have to be like super duper accurate, but there you go. So key features, I've got a y-intercept of 1. This guy has a y-intercept of 1, and it's got an asymptote at y equals 0. Okay, so let's graph 1/2 x minus 2 plus 1. So things that are different is all of these points are getting shifted right 2 and up 1. So if I take this point, I'm going to shift it right 2, 1, 2, and up 1. So that's the new location. Just going to do that to every point. Then this point's going to go right 2, up 1. This guy's going to go right 2, up 1. This guy's a half, so he's going to go right 2, up 1. This guy's a quarter, so right 2, up 1. So my new graph is going to look like this. And I now have a y-intercept of 1, 2, 3, 4, 5. So my new y-intercept is 5. 1, 2, 3, 4, 5. Which makes sense, right? Because if I took this equation, wanted to see what my y-intercept was, I just plug 0 in for x. Then I would get 0 minus 2, so I'd get 1/2 to the power of negative 2, which is 2 to the power of 2, which is 4 plus 1, so that's 5. Okay, so that totally makes sense, y-intercept of 5. And then I will have an asymptote at y equals 1. So you can see my shift of up 1 affected my asymptote. Now it's getting moved up 1. So my new asymptote is right at 1. Let's try another one. Okay, so here I've got y equals, or f of x equals 3 to the x. So quick sketch of that. I know it's going to have a y-intercept of 1. I know when x is 1, y will be 3. When x is 2, y will be 9, so it's probably not going to fit on my graph. And then I'm going to get like, when x is negative 1, I'll get 1/3. So it's going to get pretty small. So all these guys are going to be pretty small numbers. I'm going to graph them. It's going to look like that. That's my 3 to the x. Okay, so now let's graph. This one just has a 2 in front of it. So all that's happening here is a vertical stretch of 2. So if we have a vertical stretch of 2, vertical meaning all the y values are getting multiplied by 2 because they're getting stretched by 2. So I'm just going to look at every point's y values. So if I look at the y-intercept here, the y value is 1. 1 times 2 is 2. So it's just going to get stretched vertically. If I look here, my y value is 3. So if that's getting stretched by 2, 3 times 2 is 6. 1, 2, 3, 4, 5, 6. Here I had a value of 1/3. So that value is 1/3. So that's getting multiplied by 2. That's a value of 2/3. So 0.6. So it's not like a ton different, really. So down here, I'm not really going to graph that very accurately. So my black original graph had a y-intercept of 1, and it had an asymptote at y equals 0. My new graph has just a different y-intercept. So now it's got a y-intercept of 2, and my asymptote stays the same. Asymptote is still y equals 0. Okay, let's try this guy. Okay, so original graph is 2 to the x. So I'm just going to graph my y-intercept. When x is 1, y is 2. When x is 2, y is 1, 2, 3, 4. Then it starts getting smaller and smaller. So my graph's going to look like this. 2 to the x. Okay, so my red graph, I've got a negative thing and a 2. So those are both k values. So when k is negative, it means we have a reflection in the y-axis. So this axis right here. So all of our points actually go on the opposite side of the y-axis. And then this 2 here, it's a number that's bigger than 1. So I know it's going to be a horizontal compression by a factor of 1 over k, if you remember that. So by a factor of 1/2, and it's horizontal compression. So horizontal meaning x. So all of my x values are getting multiplied by 1/2. So this is telling me all of my x values are getting multiplied. Let's write that a different way. Multiplied by 1/2. Okay, so let's try that. Okay, so first I'm going to apply my compression, and then I'll reflect it. Okay, so first let's start with our y-intercept. It's at 1. It's right on the y-axis, so that means it's not going to do anything with our reflection anyways. And our compression, it's going to multiply the x value by 1/2, but x is 0. So 0 times 1/2 is still 0. So it looks like this guy is going to stay right there. Then let's look at our next point. So it's got an x value of 1. So if I'm going to multiply that by 1/2, 1 times 1/2 is 1/2. So instead it's going to become 1/2, but I'm going to have to reflect that on the other side of the y-axis, so instead it will be negative 1/2. So I'll have a point right there. Okay, then I look at this value right here, and it's got an x value of 2. So if I multiply 2 by 1/2, I get 1. And then I want to put that on the other side of the y-axis, so here I am at negative 1. And then let's look at this guy over here, that's 1/2. Okay, so my x value is negative 1 here. So if I multiply that by 1/2, it's going to be at negative 1/2, and I want to put that on the other side of the x-axis. It's going to be right here. So that's good enough for me to graph. So I see, it's just going to look like that. So really our y-intercept and our asymptote haven't changed. So both of them have a y-intercept of 1, and both of them have an asymptote at y equals 0. Okay, so what you want to be able to do by the end of this lesson, that's super long, I'm really sorry, is you should be able to describe transformation. So if I give you an original function like y equals 2 to the x, and then I give you a transformed function like g of x equals negative 3 2 to the x minus 1 plus 4, you should be able to describe everything that's changing. So I would know that this is a reflection in the x-axis, And then the 3 is going to be a vertical stretch by 3. The -1 is going to shift it right 1. And the +4 is going to shift it up 4. So that shouldn't be too hard because we've been doing that for the last, or we did that like a month ago. And then you also want to be able to graph them, but I would never give you like all of them at once. I'll probably just give you like one transformation to add to your graph at a time, 1 or 2. So then if I asked you to graph transformations, you should be able to do something like, if I gave you a graph of f of x equals 2 to the x, then I could ask you to graph a transformation, like graph, I don't know, -2 to the x minus 3. So you should be able to just draw a rough sketch of that. So you should be able to plot the original function, and then you should be able to tell me, okay, well, that's a reflection in the x-axis, so I know my points are going to get reflected like pretty much like that. But then I also have to shift all my points down 3 spaces. So after I reflect them, they're going to get shifted down. So it's just going to be a little bit farther down. So something like that. And then you should be able to figure out where your new asymptote and y-intercept is when you do stuff like this. So I know if my original y-intercept was at 1 and it got reflected, that would make it at -1, and then it shifted down 3 spaces. So 1, 2, 3. So that's 1, 2, 3, 4. So my new one's going to be -4. So I know my new y-intercept is -4, and therefore that's my asymptote is right here at y equals -3 for my asymptote. So pretty much that number is giving us our asymptote. And our y-intercept you could just get by plugging in 0 for x. Okay, so here's some practice ones you can try. Okay, so if you watched this super long, boring video, then give these a try. So we'll start with just an original function 2 to the x, because it's the easiest. And I'll give you some that you just have to describe. So try describing what's happening to these. So -2, x plus 1 minus 3, and let's do h of x equals 3 times 2 to the 2x minus 1. D to the x equals 2 to the 2x minus 1. J to the x equals 2 to the negative x minus 5. So if you can, make sure you can describe all of these for sure. Describe the transformations, step 1, make sure you can do that. Once you can do that, step 2, see if you can figure out what the asymptote and the y-intercept is for all of those. And step 3, see if you can graph all of those 4. So I'll put the solutions in another video.